So what if we change the temperature of a system at equilibrium? Well, it's going to shift to minimize that change. We can think of heat as being a reactant or product. And here we're going to assume that things are happening at constant pressure because that makes things easier. So when we have an exothermic reaction, exothermic giving off heat, right? So heat is a product. An endothermic reaction takes in heat. We can think of heat as being a reactant. So then if we're adding heat, that's like adding a reactant. If we're increasing the temperature, it's like adding a reactant for an endothermic reaction. If we have an exothermic reaction and we raise the temperature, that is equivalent to adding heat, to adding a product. And that'll cause the reaction to shift to the left. Changing the temperature also changes the equilibrium constant. Important to remember. If we lower the temperature of an exothermic reaction, that is like removing heat, removing a product. It'll shift to the right. Again, the rate constant, not rate constant, equilibrium constant is going to change. So many K's and M's. If we have an endothermic reaction, the effects are opposite. So this is that N2O4 NO2 reaction that we looked at earlier. The N2O4 is a colorless gas, and NO2 is brown in color. And so we can take a tube containing this gas or gas mixture, and if we bring it to a low temperature, and that's minus 75, I think, right? Minus 75 Celsius. We actually have one of these tubes, and I wanted to be able to, like do this in class, but I'd have to get dry ice to do that. Ice water won't do it. But cooling this down, because that's an endothermic reaction of the N2O4 to go to the NO2, cooling it down causes the tube to become clear. If we heat it up just to room temperature, then the reaction shifts to the right and we produce the brown gas. And you can do this back and forth all day long. Any questions? It's always fun when you can actually see something happen instead of just like measuring something. So again, summary, temperature change. Again, just think of heat as a reactant or product, and then the same thing will happen as when you change a reactant or product concentration. So an example, this reaction is exothermic. What's the effect of increasing the temperature of the reaction mixture? Well, what does exothermic mean? Is heat a reactant or a product? It's a product. Exothermic, heat going out. So heat's being produced. So if I increase the temperature, it should shift to the left because I'm adding product. What if I decrease the temperature? Shifts to the right.